Greetings everyone, you're welcome once more to MEPH, your YouTube channel where we solve problems on math covering different topics. Although in the previous video I've been able to solve this question, today I'm going to solve it with another approach where we can be able to get more depth and understanding of such problems when we're finding in our exam. Because I understand most students are scared of questions on probability, but if you get the right understanding, there is nothing to be scared about attempting problems on probability. Right, if you don't mind, you can pause the video, attempt the question. Please don't forget to hit the like button, comment, and share the video with your friends and loved ones. Alright? Alright, so let's quickly look at the question. I'm going to read the question while we go through. So the question says, a fair die is tossed twice, okay? A fair die is tossed twice. What does that mean? It means that we have a die. Of course, a die has how many sides? We have 6 sides. We have 1, 1, 2, 3. Okay, 1, 2. These 3 sides. Then behind we have 4, 5, and 6 dots. I know we've all seen die. So now the die is tossed, okay, twice. The fair die is tossed twice. What is the probability of getting the sum of at least 10? So the idea is this. For the die to be tossed twice, it means we are going to toss it once and we are going to toss it twice. Okay? So it's tossed once, then it's also tossed twice. So let's understand what we mean by tossing it twice. Remember in my previous video I said, if you toss it only once, the sample space is 6. Okay? So we have 1 appearing, 2 appearing, 3 appearing, 4 appearing, 5 appearing, 6. This is for once. Okay? But if you have to toss it twice, okay, you have 1, 2, 3, 4, 5, 6. So this is twice. So if you are tossing a die twice, it means you multiply 6 times 6, which is going to give you the sample space. Now, the sample space is these openings we have here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. If you count all of this opening, it's going to give you what? 36. So the sample space is what? 36. Okay? Which is, this is 6 times 6, which is what? 36. Or say 6 raised to power 2. But for once, we have just 6 as the sample space. So we have to take note of that. Now let's get the number of what? Events. Now for the number of events, now if we toss the die, if we throw it once, let's say 1 appeared. This 1 appeared. Okay, right here. So I have, okay, 1 appearing. Now this same die, if we toss it a second time, there's a possibility of what? 1 appearing again. So 1 and 1 as what appeared. That's for the first sample space. Now for the second sample space, we can have the possibility of 1 appearing and followed by 2. So 1 and 2 can appear when you toss the die the second time. You can do it again. You have 1 and 3, 1 and 4, 1 and 5, 1 and 6. So just using one die, throwing it, we can have all this appear. Or we can also have it appearing this way. So instead of 1 and 2, we can have 2 firsts, okay, and 1. So considering from this side, that's the second toss first and the first toss. So we have 2 and 1. We can say 3 and 1 from this side, so 3 and 1, so 4 and 1, then 5 and 1, and 6 and 1. If you are considering tossing from this side, okay? So now the idea is, since the question says what? Sum. Okay? So what I'm going to quickly do is, we are going to be adding the sum of what? The numbers that are appearing while we toss the die. So the idea is, getting at least 10 means we have to what? We have to get 10, 11, and 12. So all these, we are going to count them as our number of what events. So let's quickly do the tossing and adding. Now for this place, we have 2 and 2 appearing. 2 and 2, but I'm not going to write 2 and 2. So instead of 2 and 2, I'm going to write 4 because the sum gives us 4. So we have here as what? 4. Okay, here is going to be 2 and 3, which is what? 5. This is 2 and 4, which is 6. This is 2 and 5, which is what? 2 and 5 is going to give us 7. 2 and 6 up here is going to give us 8. Okay. What about this way? Let's say 3 and 2. This is 5 appearing. Okay, this is 4 and 2. This space is for 4 and 2, but we're simply going to say 6 as a sum. So here is going to be what? We have 7 and we have 8. So far, so good. The sum has not showed anything like 10 or 11 or 12, but let's continue and see what comes out. Now, what about this sample space? We have 3 and 3 appearing, so 3 and 3, which is what? 6. So this is 7, this is 8, and this is 9. Wow, we're getting close. How about this way? We have 4 and 3, which is 7. This should be 8. That's 5 plus 3. 6 plus what? 3, which is what? 9. All right. Now, the next sample space is this one. Let's see what appears. So this is 4 and 4. If you toss it 4 and 4 is a possibility, which is what? 8. Okay. So what about this space? We have 4 and 5, which is what? 9. What about this space? We have 5 and what? 4, which is what? 9. All right, so let's see what appears next. This is 4 and what? 6. Wow, so that is 10. So we see 10 is appearing. Good, so this will be counted as one of the events. All right, the next space we have 5 and what? 5. Oh, that's 10 also appearing. Okay, so that's also counted as one of the events. That's 2 events now. The next one we have 6 and what? 4, which is still 10. So this is another event, okay? So the next event is we have 6 and 5, which is 11. So we've gotten how many events? We've gotten 1, 2, 3, 4 events so far. The next one we have 6 and 6, which is 12. Count it because it's part of what we're looking for. At least what the sum of at least 10. So this, and this should be part of it. Okay, lastly we have the sample space. So let's see what event is there, 5 and 6, which is also 11. Alright, so the numbers we're having on this table, okay, this sample space that are red are the number of events, such that what we got a sum of at least 10. At least 10 means we must have 10 and above. So we have 1, 2, 3, 4, 5, 6. So it means the number of events is going to be 6. I haven't got this 6 over 36. We can now be able to get the probability of this question. So the probability, okay, PR is equal to what? 6 over 36. Of course, 6 can divide 6. So 6 cancels 6 is 1. 6 divided 36 is 6. So the answer to this question is 1 over what? 6. Alright guys, thank you guys for watching this video. I hope that it was clear enough so that when you find such problems in your exams, you can be able to attend them easy. Alright? One thing you just have to have in mind is when the die is tossed twice, we have the sample space as 36. If the die is tossed once, it's just what? 6. If it is tossed twice, so you have to use 6 times 6 times 6. That's 6 raised to plus 6. Alright guys, I would like you to hit the like button, subscribe to this YouTube channel. I'll see you guys in my next. Bye.